So here we have some of the solutions to page 241. So question 9, part A, or part I, right? So we want to find dy dx, which is the derivative of the function y is equal to x to the power of 3, x to the power of 2, minus x plus 1. So the first thing I'm going to do is I'm going to rewrite as 1x cubed, y equals 1x cubed, 1x squared, minus 1x plus 1x to the power of 0. Okay, so everything here has a power. The rule is multiply by the power, reduce the power by 1. So in this case, 3 times 1x, reduce the power by 1 becomes 2. 2 times 1x, reduce the power by 1. 1 times 1x, reduce the power by 1 becomes 0. Plus 0 times 1x to the power of minus 1. So in this case here we have 3x to be squared plus 2x, 1x to the power of 0, and we know that x to the power of 0 is just 1, so our answer is 3x squared plus 2x minus 1 is your derivative. Okay, and just take your time with those please at this stage, folks, right? Now, that's question 9 for you. Question 10. We have f of x, so question 10, f of x is equal to x squared minus 2x plus 12. Part 1, we want to find the derivative of x. Okay, so the derivative of x is going to be f dash of x is equal to, multiply by the power is 2 times x, reduce the power by 1, minus multiply by the power, which is 1 times 2, becomes x to the power of 0. This is x to the power of 0, so plus 0 times 12, and because of the 0, our answer will be 2x minus 2x to the power of 0 plus 0, which we know is 2x minus 2, because x to the power of 1 is x, and x to the power of 0 is 1. And from that we know that minus 2 times 1 is just minus 2. Okay, part 2, we want to evaluate the derivative at 100. So here we're going to let x equal to 100, and we're going to substitute. So in this case here, in the derivative f dash of x is equal to 2x minus 2. So when x is 100, therefore 2 times 100 minus 2 is 200, take away 2, which is 198. Okay, and that's question 10 for you. Okay, question 12, we have y equal to x to the power of 3 minus 3x squared plus 2x, take away 8, and we want to find part 1, find dy dx. So in this case, again we're going to multiply by the power, so dy dx is equal to 3 times x reduced to power by 1, 2 times 3 reduced to power by 1. This power of 1, so 1 times 2x, power of 0, minus, and we know the derivative of a constant will be just 0. Okay, which gives us 3x squared minus 6x plus 2x to the power of 0, which is 3x squared minus 6x plus 2. We know what happens to the minus 8, so the minus 8, question mark, what happens? Derivative of a constant is always equal to 0. Okay. For part 2, we want to evaluate dy dx at x equal to 3. So in this case, dy dx is equal to 3x squared minus 6x plus 2 at x equal to 3, giving 3 times 3 squared minus 6 times 3 plus 2, which is equal to 3 times 9 minus 18 plus 2, which is 27 minus 18 plus 2, which is equal to 11. Okay, the important bit here is the derivative of a constant is always 0. Okay, question 12 and question 14. So question 14, y equals 5x cubed minus 2x squared minus 12x plus 10. And the first thing we want to do is to find dy dx. So dy dx will be equal to 3 times 5 reduced to power by 1, 2 times 2 reduced to power by 1, minus power of 1, 1 times 12 reduced to power by 1. And we know that the 10 again is going to become a 0. So 15x squared minus 4x to the power of 1 minus 12x to the power of 0, which leaves us with 15x squared minus 4x minus 12. Okay, again, x to the power of 1, it's just x, and 12x to the power of 0, well, x to the power of 0 is just 1. Okay, and then part 2, evaluate, so find the value dy dx when x equals 0. So in this case here, we know what dy dx is, minus 4x minus 12, at x equal to 0, so 15 times 0 squared minus 4 times 0 minus 12 is just equal to minus 12. Okay, and so that's your first derivatives for you. And then page 242, so on to page 242, we had some second derivatives, and we had question 5. So f of x is equal to 3x cubed minus 9x plus 2. Part 1, find the second derivative. Okay, in order to find the second derivative, we need to find the first derivative. So the first derivative, 3 times 3 reduced to power by 1 becomes 2. That's 1, so 1 times 9 reduced to power by 1, and we know 2 is going to go to 0. So the first derivative is equal to 9x squared minus 9x to the power of 0, which gives you 9x squared minus 9. Okay, and then we want the second derivative, which is the derivative of this, which is 2 times 9x reduced to the power by 1, and we know that minus 9 is going to become 0. So it gives us 18x to the power of 1, which is just 18x. Okay, and hence the second derivative, so f double dash at 2. So in this case here then, 18 times 2 is equal to 36. Okay, so we know what the second derivative is, and we're substituting in 2. Okay, and that's question number 5. Okay, and question 6. We have f of x is equal to x to the power of 3 plus 3x plus 2. And again, we want to find the second derivative. Okay, so the second derivative, we find the first derivative first, multiply by the power, reduce the power by 1, multiply by the power, reduce the power by 1, and we know derivative of a constant will be 0. So my derivative will be 3x squared plus 3x to the power of 0, which is just 3x squared plus 3. And to find the second derivative, multiply by the power, so 2 times 3, reduce the power by 1, and we know that 3 is going to become 0, which gives us 6x to the power of 1, which is just 6x. And then for part 2, we want the value for which the second derivative is equal to the first derivative. Okay, so the second is equal to the first. So my second derivative is 6x equal to first derivative 3x squared plus 3. So in this case, 0 is equal to 3x squared. Bring over the 6x, becomes minus 6x plus 3. And now we have a quadratic. Okay, so we can divide across by 3, and we get x squared minus 2x plus 1 equal to 0. And we want to solve for x in the quadratic. Okay, so that takes you back to your quadratics. Okay, for revision for you, you have your x squared, your minus 2x plus 1 equal to 0, and you're going to solve quadratic. Okay, you can use a is equal to 1, b is equal to minus 2, and c is equal to plus 1. And I'm just doing this as a revision, so this is more so a revision for you of the quadratic formula. So x equal to minus b plus and minus b squared minus 4ac all over 2a. So you can see differentiation is bringing you back to your algebra. So in this case here, x will be equal to minus, b is minus 2, plus and minus, b is minus 2 squared, minus 4 times a is 1 and c is 1, all over 2 times a is 1, which gives you plus 2, plus or minus 4 minus 4 over 2, which gives you 2 plus or minus 0 over 2, which gives you 2 plus or minus 0 over 2, which gives you 2 over 2, which is just 1. So x is 1. So the question wanted the value of x for which the second derivative is equal to the first derivative at x equal to 1. Okay? So that's just revision of a quadratic as well. You can do that by factorizing if you like, but that's no harm to see some revision.